So in that last video, we have learned how to use the synchronize keyword and how it's allow one thread at a time to a critical section, right? And we also seen block level, right? Okay. So now we'll in today class we'll go into the details. Okay. So if someone asks you, right, what exactly what is the need of synchronized keyword, right? So if someone asks you, can you explain in simplest way what is the need of synchronization? What is synchron? Why we need it? I have already given so many examples in the last video. Okay. Again, okay. Again, I'm giving. So you just give a real-time example. Okay. Uh, you just give an example you might have seen, right? In office, school, and colleges, we used to have one printer, right? So let assume you are having a printer, and in an office there are 5 employees, right? And they're all 5 employees, right? Let assume there are employees Ram, Syam, Mohan, and Abhinav, and one more employee you just take yourself, okay? And they all try to print a document in a single printer, right? So what happened at the X time, at the same time, they all 5 try to print the document, and there is no coordination between them. Like they are not communicating with each other. Like Ram is not going to inform Syam, like I'm going to print, and then you will use the printer. Mohan is also not communicating with Abhinav, and they all try to print at the same time. So in that condition, what happened? So in that condition, your printer, right? It will be like it will be how it will behave. It will behave like overheaded, overloaded, right? And you don't know which task to process first and which to second, and it's jumbled, right? So to avoid that scenario, we use synchronization. And the scenario just now I explained you, right? We call it race condition. So when you go to Java interview, they will ask you what is race condition. So you said, so whenever they will ask you what is race condition, okay, you just 1 second, let me check I'm recording or not.
Yeah, it is recorded. Yeah.
So you just explain the same example that I've given. Let us assume in an office there is a single printer and we are having 5 employees. All the employees same time try to print a document, and then there in a certain point the printer got jumbled inside overheaded, don't know what to do, which to print, and it behave uncertain behavior you can see on the printer, right? So we call it jumbled, right? So that condition, right, when multiple thread try to access a critical section at the same time, right? So that scenario we consider as race condition. And real-time example, real world example, you can give that one, the printer one, okay? And to avoid the race condition, right? To avoid the race condition, 1 second. Are you guys there, right?
Yeah, you're there.
Sorry, I got a call. Okay. So what happened to avoid that race condition? We are having a synchronized keyword. Okay. So what synchronized keyword do? So basically it said, okay, so if I put that printer into synchronize inside a synchronized keyword, right? If I make that printer synchronized, so what happened? So let assume if Ram, Syam, Mohan, and Abhinav all try to print at the same time. Okay. So it will first, the person who first reach there, fraction of second also different. So that person will acquire the lock, and that person complete his and her task, and then next person, right? So so uh, there is a sense of synchronization that we achieve, right? So there is very low chances of having a race condition if you use synchronized keyword. Okay. So when someone asks you what is the need of synchronized keyword, you just explain this real-time example and then you explain in Java, we can achieve synchronization in two ways. Okay. The first one is mutual exclusive. Okay. And the second one is inter-thread communication. So how inter-thread communication? Like interviewer will ask you because may he have idea, he have not, right? Okay. So you just explain. Let us assume if Ram is going to print, right? So Ram come to you and said, okay, you don't print. First, let me print, and then you will do that. So that is with the help of communication, right? They can solve that race condition problem, right? So, and there is another way which is mutual exclusive. So they will ask what is mutual exclusion means, right? So what do you explain? So mutual exclusion means nothing. It's a fancy term. It's the simplest meaning is, let us say you are having a piece of code, right? Or let us say take an example of printer, right? So at a time only one person can access a printer, and that scenario we call it mutual exclusive. Okay, and we can achieve that thing in so many ways. The first way is by using synchronize keyword with method level, by using synchronize at block level, by using synchronize at static block level. Okay, and then there are locks. Okay, so what is locks? Like you may get idea. So we'll come to know that. So let assume when you let take example of yourself, and let us assume there is a room or there is a printer. Let's take a printer. So first Kritika go to the printer and she acquire the lock, she did his task, and she then release the lock. Once she released the lock, Poonam went to the printer and she lock that printer, and lock in the sense acquire that, control that printer, okay, for her task. And then once her task is done, she release the printer, and then again Ponita went. So like that. So that is called lock. That locks we have. Okay. So how locks are different from synchronized keyword and all we read today. Okay. So there are four types of lock that we have to learn: monitor lock, intent lock, read and write lock, stamped lock. Okay. This is the most famous one, and mostly interviewer will ask the difference between these two. Okay. And then we are having inter-thread communication. The first one is waiting. Sorry, wait, notify, notify all. Already we have seen in the example. We'll see more. So what happened? How one thread can communicate with another thread with the help of wait, notify, notify all, right? Okay. Now there is another way to communicate. Another way which can help thread to communicate, the semaphore and countdown latch and cyclic barrier. So these two are the advanced topic, not advanced topic. It's a basic topic, but most of the interviewer ask what is countdown latch, what is cyclic barrier. Can you give an example of countdown latch and cyclic barrier? Okay. So now if someone asks you what is synchronization, what is race condition, okay, how we can achieve synchronization, so you can say that by using synchronized keyword method level, by using synchronized keyword static level, right? Inter-thread communication and all, right? Clear to you all?
Yeah. Yes.
Okay. Okay. So now first we'll go through this mutual exclusive one, inter-thread communication. Basically, we have to know that, okay, what is semaphore? One example. What is countdown latch? One example. What is cyclic barrier? One example. Okay. With one example, you guys can easily understand. Okay. So first, we'll come to know that about all the locks that we have, because blocks or synchronized block already we have know, right? So synchronization we can achieve in two ways: with the help of locks and with the help of block. Sorry, synchronized keyword, which we can use on block level and method level, right? Okay. So when you use, when you use synchronize keyword, that is also a lock. Okay, we call it, that is monitor lock. So if someone asks you what is monitor lock, so you can say if you want to achieve a monitor lock, you use synchronize keyword. Okay, so they say then what will happen? So you just explain. So when you use synchronize keyword, in that scenario, what happened? Every object has an implicit lock. Okay, that lock acquired when entering into the synchronize method or block. Okay, and that lock we can enable by using synchronize keyword. Clear? So if thread try to access that block with the help of object, that object enables the lock for the critical section. On the task is done, the object will release that task. Okay, so we'll see some example, then you guys can. Okay, the first one is monitor lock. Okay, so monitor lock, to use the monitor lock, what we are doing? We are using synchronize keyword. Nice. Okay, so now synchronize keyword we can use in two ways. First is method level. So let us having method, already explained that one, and then block level, that also already explained. Okay, if you guys got any doubt, you have to ask me. So block level already explained in the last video. So you everyone, like, you've been through the video, right? Or any question you have?
Abhinav, tomorrow, because today I finished my exam and everything is over, so I will go through the video tomorrow,
Okay.
actually.
Okay, so you
And
guys
if I
know.
have any question, I will just put it in the
Yes.
message.
Yes. So you might have question related to understanding, but how to write syntax, right? So syntax was clear. I will go through the syntax once again. So basically what happened, let assume how you define a general method, right? M1 is a method. Nothing there. You are using here synchronize keyword for block level. So let assume M1 is a method. Inside you are having a block. Inside you are having a block. Even here you can use, one second, synchronize keyword, and then this will point to a current object. If you have any other object, you can directly name that object here. Okay, this is a syntax which already we have covered in the last video. Okay,
So that parameter is mandatory. I know that this.
yes, this parameter
Okay.
is mandatory. this
Okay.
this one is mandatory. Okay, so first we go through the video, might have question. Okay, after this, all this detail, right, the theoretical details, when we write a program, we know more about the flows and all. Okay, but first we have to go through the theory. Okay, so now monitor lock is clear. Now second lock is called, just you guys have to know the package, how to create the object and everything, and other than that we'll see in the example. Okay, so what happened, this, all the locks that we have, right, intent lock, read write lock, stamped lock, they all belong to, definitely there would be a package, right, util dot concurrent package, concurrent dot locks dot, then you just do dot star, all the locks will, if you have a specific locks, you can just import that. So what happened, what is reintrant lock? So basically it's allow thread.
Abhinav, sorry.
Hmm.
1 minute. Yeah, the thing is, you said the monitor lock is acquired by a thread, right?
See, oh, yes.
No,
So
yeah, it's actually for synchronization, right?
yes, yes, yes.
Yeah. So what if some other thread has acquired that lock?
Yeah, I will tell you. So what happened?
Okay.
So that is the disadvantage of this synchronization, which is monitor log. So what happened in monitor log? There are multiple things that we face issue. Okay. So what issue we face? So see, let's assume you are having a 2 or 3 or 4 threads, right? And when you are going with the mutually exclusive logs, which is monitor log. So monitor log, what happened? So it's, let us assume Ponita acquired the log, right? Now me, you, and others are waiting, right? So first it increase the waiting time, right? Okay. Now let us
Okay.
assume I use thread.sleep, right? So what happened while doing a work, I make you sleep, right? And then I allow Ponita to use it. So what is happening? So when you go to the sleep, then again you wake up. So what you are doing? You are doing a context switching, right? Right.
Okay. Okay.
So,
Okay.
so context switching overhead, it's like frequently sleeping and waking up, right? So what happened? It will,
Okay. Then we have to wait so that once it is released, then we can acquire that lock.
yeah. So no,
Okay.
even you, if you use simply synchronize, there is a reason that we are learning these logs. Okay.
Okay.
So
Okay.
what happened when you when you only use synchronize, right? So this type of scenario occur. So there is a scenario called, what is they call starving. A thread went to a starving mode. So one thread is starving, is not getting the resource, and he may never get the resource, right? So let assume you are having 5 thread. Let assume, okay. Now I'll give you a scenario. It's first we have to understand. Let assume right now one printer is there, right? And let's think there is a fridge also next to the printer, right? Now Kritika acquired the lock on printer. Now Poonam got angry. What she did is she went to this fridge, right? And she acquired the lock on fridge. Now Kritika is saying, first you release the fridge, first you give me access to the fridge, then I will give you access to the printer. Poonam is saying, no, first you give me access to the printer, then I will give you the access to the fridge. Understand?
Okay.
So in that scenario, what happened? It's a deadlock, right? So,
Yeah.
so what happened? So it's not simply if you write really poor code, right? Even with synchronization, there is a chances of deadlock, right?
Yes.
If you maintain, if you not write a clean code, if you use synchronize keyword in inconsistent manner, right, or inconsistent order, right, at the same time you are allowing two thread to two resource, and after completion, let us know, after completion of their task, they both need each other resource, right? So in that case you will get deadlock, right? So, and starvation, how it will occur? Let us assume one thread is using it and it's keep doing it, it's not releasing at all, understand? And other thread is keep waiting. Okay.
Yeah.
So that is the issue that we have with simple plain synchronization keyword, which is called monitor log. Understand? So with monitor log we have that issue. So the possible solution for the monitor log is reintrent read and write log. Okay. So in read and write log, what happened? So at a time multiple thread can read, right? And one thread can allow to a common section to write, right? There is a method called try log, right? Correct. And there are other approaches also. Compare and swap, atomic variables are there. Okay. So in that case, what happened? We avoid this type of issue that we got with the basic locking mechanism, which is synchronized keyword. You guys are able to understand, right? What I'm saying?
Yeah. Yes. Yes.
It's may not make sense right now, but when you type
Yeah.
the,
It's actually theoretically we are just imagining things.
yeah,
It's actually
so it's,
that's how I'm understanding it.
yes. So it's like, see, before this threading, right? If you're not able to map to real time, you cannot write a single line of code. Even you write also, you just memorize, you will not understand. Okay. So always map to the real time. Simply like, see how two brothers are fighting, right? As two small kids, right? So one kid is holding bat, another kid is holding ball. Okay. Just assume that there are two threads, right? And one kid is saying, first give me the ball. Second kid is saying, first give me the ball. And they are not able to share these resources, and that is the reason they are not able to play the game, right? So that is called deadlock. So first they have to release their resource,
Okay.
right? How they can release the resource, right? So we cannot see deadlock if in Java, if deadlock occur, then your application crash. There is no possible way to recover from deadlock. Okay. The only thing we can do is we can write a preventive code, right? So deadlock can never occur. Understand? Okay. So we are there.
Yes. Yes.
So we are at the monitor log. Okay. So now come to the rent log. Okay. I will give you this link also, a Medium link, where I have noted down everything. Okay. So all this theoretical thing. So in rent log, what happened? So let assume one thread acquire the access, right? And it's release. If he want to reacquire that one, okay, so he can reacquire also. Okay. And it's also having a try log. Okay. And there are called fair logs that we see while writing a program, we'll see. So basic thing, retent log, how to create object. Okay, we'll first better to create that one. Okay. So simply if someone asks, can you create an object of retent log? It's straightforward, nothing there. So go to your main class, okay, or go to any other class, anywhere, you just create a object of retent log. How to create that one? So always use private and final. Okay, private, final. Why private and final? You can without this also. So locking is for internal use, right? There is no use of locking outside your method, right? Because you are writing the core logic. So you don't want to change the lock properties and all. So there is no need to make it non-final. So private, final, and then you will type simple, then create object obj or lock, whatever name you want to give. So you just created a lock. This is a simple, straightforward. Okay. Once you created it, let's think you are having a method and you want to make that method synchronize, right? So let us assume you are having a method called public void m1. I am writing, I just assume this is inside a class. Okay. It's not like you will say, okay, m1. Okay. And now curly brace started. 1 second. Just wait a minute. Okay. So curly brace started here and curly braces end here. Okay. So in between. So now let us know I'm writing. So I have obj that I created, which have a method called lock lock. I just enable the lock here. And then I use try and catch. I just print system.out.println. I am just saying hello world. Hello world. I'm making that thread to sleep so that other thread can get access. Thread dot sleep. This is okay. And then I'm just typing again. It was like hello world, and I'm just writing done. Whatever you want to write, you can write. No issue. This is try, and then try will end up with catch, right? Where we are accessing exception. So you can directly write exception E. Okay, inside the exception, you just print whatever you want to print, and then you are having a finally. So what I'm going to do in finally? Any guess? So basically, this is the method, right?
Yeah.
At the start of the method, I enable the lock, right?
Yes. So you have to release the lock.
Yeah. So once your task is done, right? Once your execution is done, you make sure you are releasing the lock. Let us assume if you not release the lock, then what happened? Then other threads, right, who are waiting, they go
Stop.
into a starvation mode, right?
Yeah. Yeah.
So it's like you go inside the kitchen and lock yourself. You are not coming out, right?
Okay.
So it's like obj, whatever name you have given, and there is a method to unlock.
Unlock. Okay.
Okay. I am writing unlock in finally. Okay. It's your wish where you want to write. Okay. But always you have to write inside of finally. Why? That reason you
But
get.
if you write it in the try block and it get exception is caught, and then again it will go to the starvation mode, right?
See,
No?
that is the thing. Finally, always execute, right? There is only one.
That's what okay.
So even you got the exception, finally will get executed, right?
Yes. No, you said that you can write unlock anywhere you said. So that's why I
Yeah.
asked.
Yeah,
Yeah.
correct. So if let's assume if you write in catch, an exception never occur, right?
Yes.
So that is the thing. So it's
Okay.
you can write anywhere, but it's better to write.
And finally.
And I think compiler will definitely tell you this. Nowadays compiler are very advanced, right? IDs, right? They will tell you why you are writing in catch. Don't write it.
Okay.
And if you want to write it also, like if you get exception, you just want to release it, right? That is also fine. But like we always write in finally block. Okay. The reason is
Okay.
clear. So if anything happen except system.exit, you remember, right? Finally will get executed, right?
Yes.
Okay. So now if someone asks, can you create an object reentry lock? You just tell them this is the way to create it. Straightforward. We'll see that code as well. We left with 6 minutes. So we'll just go through each of the lock. Okay. Then tomorrow we'll have one program, again one program with the locks. Okay. Now read and write lock. Okay. So let us assume you are having a class. Sorry. So why we need of read and write lock? So if you see the previous lock, if once, let us assume if one thread come, right? And he just want to read something, right? Don't want to write something, right? But still he have to wait to what for the other thread to complete their read and write, right? Whatever they are doing. Either they are reading read and write, doesn't matter. If they are doing read, also if they are doing write also, the other thread have to wait. Okay, let's take an example. In your school, right? Your teacher is announcing everyone result, right? And there is one more person next to the teacher, like person. If you are having any issue with your paper, like you are saying, ma'am, my there is a issue like in marking, right? I'm not getting a good mark. I have there is a problem. You given me a less mark. So assistant of your teacher was there, who is only dealing with the person who is having problem, right? And others are just listening to their marks, how much they achieve, how much they score in the exam, right? So teacher is just announcing it, or just write down on the board so that all can read at a once, right? But some people are want to update their marks, so that is happening on different block with a different resource. So why to use a single lock which block everyone who is reading also, who is writing also, right? So means I just want to know my roll number. I don't have any complaint. Still, I have to wait, right? If I going with the traditional way, right? Correct. Because your teacher is serving in synchronized way. So she will first complete Kritika marks and she will ask Kritika, do you have anything to update? Is your paper is fine? Can you verify that one? So that is a traditional way. But read and write log will provide you a mechanism where your teacher said, one second, your teacher will say, no, you just, this is your mark. If you want to modify, you just go to my assistant and she will update that one, right? So what happened? So it's like your, with the same locking, multiple threads are able to read, and specific threads which just who just want to write, we just want to do some modification, right? They can go to the separate resource. You guys able to understand or not?
Yeah. Actually, the read and write, you're saying that there is two options that whoever reads, that's what
Okay.
you're saying, right?
Yeah, I will explain it. Okay.
Okay.
Just think about this. Okay. So this is a section A. This is section B. Okay. Now there are thread T1, T2, T3, T4. Okay. So what happened? In section A, the data that we have, right? In that section A, there is no modification, there is no update. So why? So it's like just reading the data. Let us assume I have written here 53. So all thread will read that 53. You understand? There is a, in section B, there is a variable X, which have value 1. So every time one thread will read that one, they will update the value 1 to 2, 2 to 3, 3 to 4, right? So in section A, which is only reading the value, and section B, where they are doing updates, right? So if I use normal log, so what happens? So let us assume this T1, T2, T3, T4, T5, in between these 5 threads, these 3 threads just want to read that data from section A. They don't want to write anything, right? But if you go in traditional way, first T1 will come, it will acquire the log, it will read, then to section B, you don't want to do anything, then he will get released. Then T2 come, then T3, then maybe T4 come, and then after that T3 come, then T5 come, do that. This is a normal synchronization. They will come here, will read, they don't do anything else, move. But in that case, what happened? Like, even though this T1, T2, and T3, who just for reading the data, they supposed to wait. Or let us assume T4 is just want to read the data, but you have to wait, right? For T4 and T3 and T5 to finish their write or finish their read, right? But when you go to read and write mode, what happens? It's saying just divide your section to read and write. So which is the read? Section A is read. Okay. So read allow everyone who have read access. It's allow everyone who just want to read. And in critical section, which is write. In write, so if anyone want to acquire a write log, they will go here. You understand? So what happened in this case? Okay. So what happened here? So we are having a class hello, which have two synchronized method M1 and M2. Okay. Where you have written this, okay, this is the current thread name, and then we are putting the current thread into the sleep for certain milliseconds, right? Same thing we're doing with M2. And then we are trying to get the scenario where both the methods are synchronized on the same object. So here my both the methods are synchronized. I created a single object of that class. Then I created two threads, A and B, and inside I'm calling h.m1, h.m2. Okay. And here I'm having starting thread 1 and thread 2. So what happened in this scenario? Because both the methods are synchronized on same object, the execution of the thread will be sequential. Sequential means first one thread will get executed, then second thread will get executed. So if you see here in terminal or in console, so which thread is getting executed first? Thread A, right? Then thread B. Clear? So if someone asks you this scenario, you can easily explain, right? If they will say there is only one object and different method, both are synchronized, then execution flow will be sequential, that you have to explain. Okay. Now go to the document that I have shared with you and you check what is the next scenario. So next scenario is both the methods are not synchronized. Okay. And both thread run concurrently. Okay. So what we will do? Simply both the method are not synchronized, right? So method are, this is a second scenario 2, right? Make scenario 2. And what we'll do here, we'll remove this synchronized keyword, right? So when we are having synchronized, the execution flow was sequential, right? Kritika?
Yes, when it's
Sequence,
both of the thread is not synchronized, then it should be free
not
sequential.
thread, both the method. Okay.
Sorry, both the method, yes.
Yeah. So if both the methods are not synchronized, so in this case, what happened? So it will be a concurrent execution. Concurrent execution means both the thread
At the same time.
execute at the same time, right? There is no sequence, right?
Yes.
So anyone
Yes.
will get executed first, anyone will get executed second. There is no sequence. We cannot, every time you run, we may get different execution flow. See here. See here
Okay.
what M1 started, M2 started with thread B, correct? So there is no sequence,
Yes.
right? Okay.
Yeah.
So if someone asks you this scenario, you can explain, right?
Yeah.
This is a second scenario.
Yes.
We are right now, we are covering synchronized keyword. And after that, we'll not visit, we'll directly move to log. Okay. So if you guys get any question for me, please ask. Okay. What is the third scenario? One method is synchronized, one is not synchronized.
Another method is not.
Okay. So let M1 is synchronized and M2 is not synchronized. So in this case, what happened? So any guess, any Poonam or you, anyone, like if you just try to explain, one is synchronized and another one is not. Everything remains same, right?
So yeah.
So what happened?
So the first one, the thread which is the method which is synchronized will be called first.
Okay. Okay.
I mean,
it's you don't have to answer the exact output. You have to say that. Okay, the first one is sequential, second one is concurrent, the third one is concurrent or sequential.
it is sequential.
Okay.
Because the thread, yeah. Okay.
Okay. Yeah. Explain. So whatever you understand, you just explain. No issue.
Because the method, that method which is synchronized will called, and then the next method will be will be called.
Okay. So
that's what I understand.
Okay, you are right. It's pretty straightforward. So if the method is synchronized, so if method is synchronized means only one thread can enter at a time, right? So which one is synchronized? M1 is synchronized means only one thread can access at a time for M1. M2 is not synchronized, right? So it can execute concurrently, right? Because M2 is not synchronized. So means this piece of code, right, where one is synchronized, one is not synchronized, is partially concurrent, right? It's not fully concurrent, right? Or you can say that partially concurrency, right? So partial half of the code is concurrent and half of the code is sequential, right?
Sequential, yes. Yeah.
So you see here, M1 started by thread A, M2 started by thread B, M2 ended by thread B, M1 ended by thread A. So it's like, it's a partial sequential kind of. So we cannot, here also we cannot say that which will execute first and which will execute later, right?
Okay.
See here B and then A, then here B, right? And here A started here, so like that. So in this scenario, you just have to remember, you just have to apply your logic and you have to say partial concurrency we can achieve. So we cover 3 scenarios, right? Yes. What is the fourth scenario? The fourth scenario is both the method are synchronized on different object. Okay. So in
Okay.
this case, we need to modify our code a bit. Okay. So both the method are synchronized on different object. So this is synchronize M1, synchronize. So both are synchronized on different object. So let me do that. Okay. So different object means I have to create two objects, right? Hello one. So there are two objects, hello one, hello two, right? And then what I'm doing with one object, I'm calling M1, with another object, I'm calling M2, and then I'm starting both the thread A and B, right? So in this case, what happened? Any explanation? Any of you guess? Like it's a concurrent or parse or sequential?
Is it a concurrent?
Yes. Why it's concurrent? Can you explain? It's right. It's a concurrent. What's why?
Yeah, because the thread is calling. I mean, it is an
The threads are
different
getting lock
object,
on different objects.
long
So there
different
is no
object. So it was
interface.
concurrently. Yeah.
So there is no interface, no interference,
Yes.
right? So
Yeah,
it means like,
interference. So it will concurrent.
yeah, because the thread T1 is enabling lock on H1, right? So it will go to,
Yeah.
it's concurrently execute
H1.
that part, and T2 also execute because
Mm.
there is no interference from H1 lock, right? Because we are having a separate
Yes.
object, means separate lock,
Yeah.
right? So let's
Yeah.
assume you are
Yeah.
two person at two rooms and they want to do work from home, they want to sleep or anything, there is no disturbance, right? They all can execute their task on separate area, right? So this is the thing.
Yeah.
Okay. So we have covered fourth point as well, right? Okay.
Yes.
So, okay. So what is the fifth one? The fifth one is, so let us, okay, let me modify the code. So make it this one static synchronize. So first one become static. Okay. Static synchronize. So in fifth scenario, if interviewer will ask you, what happens if one method is synchronized, static synchronize, another is instant synchronize. Okay. And in that scenario, how you are going to execute, how the execution flow will work, right? So what you will explain?
Sorry, come again.
So here one is static, right?
Yeah. Okay.
Okay. Another one is
Okay.
non-static, instance.
Non-static.
Okay.
Yeah.
Let me remove this. Let me remove this one. Let me use single, because even if I use single also, it doesn't make any issue, right? There is no issue, right? I'm just invoking that method M1 with reference. It's a static method, right? I can invoke with class name also, right? Let me
Yeah.
invoke with class name. Otherwise, you will get confused. So in this case, whatever. It's pretty straightforward. Like easily you can answer, right? Okay.
Is it seek?
Now, when you use synchronization on a static method, what will happen? Which object will get, which object lock will get enabled? Default object, right?
Yes.
Means different object, not the H1, right?
Okay. It is a concurrent. Yeah.
So it's a concurrent. Okay, this is the
Yeah.
trickiest one. Above all,
Okay.
this one is the trickiest one that interviewer will ask you. Okay.
Okay. Okay.
So see, it's a concurrent execution. Okay. Never follow this execution order. Okay. So it's like if you are in concurrently executing something, this, because we are having a single console, right? If you have 5 or 6 console, for each thread one console, same time you will see the print and all. Okay. So we are having a single console. That's why every time when you run, you will might have Okay. Now the last and very important, if both the methods, right? This M1 and M2 are static and synchronized, then what will happen?
Um, it is sequential because both it's the same under same class, right? So of course it's calling the same object.
Yes. So it's, yeah,
Is it
correct.
so? Yeah. So it is sequential.
So it doesn't mean, it's basically the lock will
Oh,
get
it
enabled
doesn't.
on default object. So even you use with class name or you can use with H1, okay? It doesn't matter,
Okay.
right?
Okay.
The reason
Okay.
is static, right? You are just invoking that one, right? So if
Yes.
I use different
Yes.
object also to call this different two, it doesn't, it's don't not affect the execution flow. Why? Because we are just invoking that one. The lock will get enabled on default object, and because
Default
M1
object.
M2 both belong to the same class, right? So means lock will get
Okay.
enabled on the same object, means the execution will be sequential. So let me run and check.
Sequential.
So to see, first A started, A ended, then B started, B ended. So you guys able to understand this?
Yes. Yeah,
It's
I can
pretty
understand that.
straightforward, right?
Okay.
Okay. So let me first stop the recording.
Oh, okay.
Okay. So fine. So in today class, we learn about a two topic which is very popular. Uh, the first one is countdown latch. Okay. Okay. Countdown latch. And the second one is cyclic barrier. Okay. So these two topics, right? The countdown latch and cyclic barrier, right? So first we will understand why we need it. Okay. And where we can use, basically we have to know that, okay, where we can use countdown latch, where we can use cyclic barrier. Okay.
Okay.
Okay. So first we'll take an example of countdown latch. Okay. It's an advanced topic. It's pretty straightforward and easy, but I don't know, like mostly people consider these two topics as advanced one. Okay. But I found out like it's pretty straightforward and one can easily explain. Okay. So first we understand what is countdown latch. Okay. So have you might been to a multiplex, right, to watch a movie, right? And you might been to a birthday celebration of someone, right? And once all the
Mm-hmm.
guests
Yeah.
reach, right? Once all the
Okay.
guests reach, then do this cake cutting, right?
Yeah.
Okay. So just take a scenario. If you have to write a certain code, okay, where you can only start cake cutting, right?
Okay.
So this is a cake, and you are waiting for 50 persons. Okay.
Okay.
So what happen once all these 50% reach? Okay.
Okay.
So once the last person reach, you will start cutting the cake cutting ceremony will start, right? So
Okay.
this is
Okay.
the real time. This is, and always remember, cake cutting will happen one time. So countdown latch we only use for one time event. Okay, the event which occur one time and then process start. Understand? One, okay, now take example.
Okay.
Let assume you five friends decided to go for a movie, right?
Okay.
So what happened? So you all five only go for a movie, like you only go for a movie when all the five member get together, and then you all five reach to the wherever you plan to watch a movie destination, then only you can start the movie. So this type of scenario, like, so so let assume you are hosting that movie, okay, and you are waiting for all of your remaining four friends, right? Once the four reach to your home, then only you will start movie. right? So means
Yeah.
you are the host thread. Let us assume you are main thread. Okay. And the other three
Okay.
friends, right? Or four friends,
Mm-hmm.
Ponita, me, and etc. Whatever, like Suman. Okay. So all three
Okay.
will reach, then you will start the movie, right?
Okay.
So basically, you become a main thread who will start the
And
movie.
I'm waiting for you to
You
complete
only
or
start, yeah, you only start
okay.
the movie once all the thread got started.
Started.
All
Okay.
the thread started and they reach to a certain point, right?
Okay.
So it's
Okay.
totally depend upon us. So how will keep the count, right? So let assume there what people used to do is they used to create a latch. Okay,
Mm-hmm.
just take you created a latch with the help of countdown latch. Okay, I'm just
Okay.
uh and every time let assume you are a host, you are a main method, you are a host. This is your home.
Mm-hmm.
Okay, now Avinav come.
Okay.
So now you know that total five friends supposed to come. Sorry, total four friends supposed to come, including you. It's five friend. Okay. So now
Okay.
first Avino come. So you know that four friend come. Now when Avino reach, right, you just decrease this
Mm-hmm.
one. So now three remaining,
Mm.
right? Then
Oh.
Ponita
Mm.
come. You decrease this to two. Now
Mm.
Suman come. You decrease this to one, right? Total how
Okay.
many friends come?
Okay.
Three friends arrived. One more
Three
supposed
friends.
to arrive.
Yeah. One more.
One more
Yeah.
friends arrived. So it's become
Okay.
zero. Once it's become zero,
Okay.
it's
It
like
will
start the process. You understand?
process.
It
Okay.
will
Yeah.
start the
Okay.
run, right?
Okay.
So this
Okay.
is so for this purpose we use countdown latch. Okay, and
Okay.
this is the
Okay.
countdown latch. So anywhere if you have this type of scenario, right,
Mm-hmm. Mm-hmm.
where you have to let us assume there are three, four threads, right, and
Okay.
all the threads have to reach to certain level, or all the threads once all the thread got started, then only you do some work, right? So in
Okay.
that scenario, you will use countdown latch. Okay. Let assume if you are waiting for three threads, right? Or four threads, five threads, six thread, right? So you will
Okay.
provide,
Okay.
I am waiting for six thread, right?
Mm-hmm.
Okay. So
Okay.
how we'll do that? We'll see in the code and
Okay.
okay. So basically, okay. Okay, sir, you understand, right? Or the basic idea behind countdown latch. It's not critical. The only thing is that we have to know that, okay, explain is pretty good. If I'm going for, let us say I'm hosting a movie, I'm waiting for three friends, all the three friends reach, then I will start. Pretty clear.
Yeah.
But how I know that all the three reach? If I have to write in code, right?
Code.
The first
Yes.
thread
Yes.
arrive, the second thread arrive, the third thread arrive, right? You have to write in the
Uh,
code. That is the main point.
mm-hmm.
Like understanding also good. Like we need a better understanding of any concept, but with understanding as well, the writing a code is also much important, right? So what happened
Yes.
to this type of scenario? So there is a class call, we call it countdown latch. The class call
CountDownLatch.
countdown latch. This is a class name. Okay.
Okay. So you have to
So
import it.
basically, I will give you the idea, then I will write the code here. Okay. And tomorrow,
Okay.
anyhow, we'll
Okay.
have the proper code. So basically, what we
Okay.
used to do, we used to create an object of this latch. Okay.
Mm-hmm.
And
Mm-hmm.
every time when run method is accessed by one thread, right? If one, let us say thread one arrive to a run method, we decrease
Mm.
that one. So we use a method called count down, means decrease the count. Okay.
So this class is used to, I mean, count the thread
No, yes,
or
kind of.
okay. Yeah,
This
kind of.
class is having a method called countdown, which help
Count
us
down
and which help us to decrease the latch.
thread.
And okay,
Yeah,
now
latch. Okay.
yeah. So now latch, if you see, if I have to create the latch, right? I will create latch and then I can go here, I can create new latch, new countdown, right? New countdown latch and pass 4. It means simply I'm saying I'm waiting for
It
four
has to
threads.
wait for
Okay.
4 threads. Yeah, so it has to run for
It's not kind
yeah,
of wait. It's like it's keep a count of four threads. Okay.
4 threads.
Okay. and I will demonstrate everything. Don't worry. Okay.
Okay.
So we'll have a basic code here. I will write a basic code and then we'll go to cyclic barrier. Okay. So countdown let's just understand like always for me, if I have to understand the countdown latch, I will always take an example of cake cutting, which make more sense to me. Okay.
Okay.
Okay. Because you are having a cake cutting ceremony, I'm a host and I'm waiting for 5 or 10 members. Each member is coming inside. I'm keep decreasing the latch. Once the latch becomes 0, I will start. It means like the countdown latch is over. Now all the process is good to go, right? And
Okay.
good to execute, right?
Okay.
Well, we'll see. So first of all, we are waiting for friends. Okay. So what I will
Okay.
do, I will take a class called friend.
Okay.
Okay. Okay. Now I'm creating each thread is going to represent my friend, right? So what I will do, I will make this class
Extend thread.
extends thread. Clear? Okay.
Yeah.
Now I have to keep a count of because I am using a countdown latch, right? So I'm waiting for
Okay.
50 friend or 10 friend. Let's take 5 friend. Okay. So I'm waiting
Okay.
for 5 friend. So I will do one thing. I will first here take reference private count down latch and then LCH. I'm just taking LCH. Okay.
Okay.
Okay. So the countdown latch, I have taken a property in a friend class. Okay. Now I will create a constructor. Okay.
Public friend.
Okay. So friend, and then I will have here,
Countdown. Yeah. Okay.
I will
String.
have a string name for the thread. You remember like when we are creating thread, if you want to pass a name by extending thread class, if you want to assign a name to a thread, we need to pass that name to a super class, right?
Yes.
So here I will count down latch
Lash.
LCH.
Let's see.
Okay. And now this name we have to pass
This
where? Super class.
super class. Yes. Super dot.
So it will become
Oh, super.
no need to do dot
Oh, yeah.
direct.
Super name.
So this is fine. Now
Yeah.
this
This
dot
dot
LCH,
LCH.
right? LCH equal to
LCH.
LCH, which I will get. Now constructor is done, right? Okay.
Yeah.
When you extend a third class, you need to override, right? Run method.
Run method. Yes.
Yeah. Public void.
Run.
Okay. In run, I'm not doing anything. Okay. I'm just
Okay.
printing system.out.println and I'm just printing a thread name. Like all the guests,
Yeah.
your guests supposed to arrive, right? So
Yes. Thread
guest
dot
or friend, whatever it is. Okay. And then I will write
thread dot current
thread dot
current thread dot
thread dot current
get name.
name dot get name.
Current
Okay.
thread dot get name. Yeah.
Yes. And then I will
Yes.
once guest arrive, right?
Okay.
Then what I will do? I will do LCH dot. There is a method called countdown.
Okay.
So it
We'll
will
call
automatically
them.
decrease. So what it will do?
Okay.
It will
So whenever a thread, okay, whenever you
Hmm.
get a thread name, it will decrease one
it will decrease a count.
size one. Yeah.
Okay.
Count.
Now
Yeah.
till
Yes.
now we don't know how many threads we are waiting for, right?
Yes.
So void and the class is end. Okay.
Okay.
So what we
Okay.
have to do now? We have to create a thread and we have to
Opt
create a latch, right?
latch.
That
Okay.
latch will pass, right, to friend
That
constructor.
how many thread we should. Okay.
Yeah, it is a part of main class, right? So let me define a main class.
Yes.
Okay. Or we can have a
Okay.
public class example. Okay.
Okay. Okay.
And then we are having here main method. I'm just writing this one.
Yeah. Yeah. Okay. That's okay. I
So
understand.
main method and class end here, and in between I will write the actual code. Okay.
Okay.
Okay. So how many friends you want to invite, right? So let's assume you
Okay.
want to invite
Fine.
count down latch LCH equal to new
New
countdown
countdown latch.
latch, and I have given 5 friends. Okay.
Okay. Okay.
So I'm waiting for 5 friends. Okay.
5
And
friends. Yeah.
then what I will do, I will directly,
Right.
I will write here new friend, right? And I will write here Abhinav, right? And then I will write here LATCH. Sorry. What is this name? This is latch LCH.
LCH.
LCH. And I created the thread. I can directly start here, right?
Okay.
I can have in reference also. I can start directly also. I can start. Okay. So similarly,
Okay.
my new friend Abhinav latch start I did. Similarly, what I do, I will create,
Again.
yes, 5
Oh.
friends you want, right? So you
Yeah.
have to
Okay.
create 5 threads, right?
5 threads. Okay.
So Abhinav, then Rakesh, and then you will LCH, and then you will start that thread, right?
Okay. You will
Similarly,
start 5
first, second,
threads.
third, fourth, and the last one is fifth. I'm just directly creating it because it's a repetitive code, right? And I added
Okay.
Ponita, okay, and then LCH,
Okay.
and then dot start.
Okay.
So total how many? First, second
5.
thread,
3.
third,
Okay.
fourth,
5.
and
Yeah.
5. 5
Yeah.
thread I have created, right?
Okay. Okay.
Okay. Now what I will do, once the I will this LCH is having a await method. Which method? Await method. I will call here await.
Okay. It's await. Okay.
Yes. So
So
what
it
it
will
will do,
wait till the
it
all the
will wait
threaders. Okay.
until this latch becomes 0. Means till all the friends arrived. Okay.
All right. Okay.
So
Okay.
it will wait till latch become 0. Once latch
0.
becomes 0, then only
It will
all the
start the
friends will arrive
cross.
here. So once we reach this point, I will write here system dot SOP start
The
cake
processing. Okay.
cutting.
Okay.
You understand this?
Yeah. 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 Okay. Yeah.
So pretty straightforward.
Okay. Yes.
Okay. So every time
Okay.
what happened, you created latch here, right? With 5. Then what happened, you created a first thread. Okay. I'm directly creating this. You can create like friend, Abhinav, new friend, Abhinav, LCH, like that, right? And then you call a start on each thread. Okay. But I'm directly doing that to save time. Okay. And then
Okay.
once all the thread is started, you just wait. You will write LCS dot await. So it will wait for all the thread to arrive. Once all thread arrive, you will do your task. Start cake cutting. Okay.
Okay.
Clear?
Yes.
Okay. So now this countdown latch is clear. So we'll move to cyclic barrier. Okay.
Okay.
Cyclic barrier. Okay. It's not 2 word. It's a same. I'm just breaking that so that you can easily cyclic and barrier. Okay. Okay.
Okay.
So what is the use of this cyclic? How it's different from countdown latch? So how it's different? So you just, okay. So countdown latch is for one time event. Okay.
Okay.
So cake cutting is a one time. Once everyone reach, a cake cutting happen. But cyclic barrier is for repeating event. Which type of event? Repeating
Repeating.
event. Okay. So what is repeating event? Okay. So have you seen anytime cycling race?
No, but yeah, I can imagine. I've never
Okay.
seen.
So just imagine a cycling race, okay,
Okay.
where 3 cyclists, okay, waiting for the checkpoint before continuing to the next stage. So let's assume if one cyclist cyclist completed one lap, right? For
Okay.
next lap, he have to wait, right? To all these two cyclists to reach to the point, right? Then next, right? When all three
So you're saying
cyclists
it's like a relay?
kind of, you can say that. When a
Okay.
relay in the sense, relay you are talking about
Re
in the context of cycling.
no, it's in the context of running. So one will run
Yes,
and
yes, yes.
then when they reach a point, another will run from there. Is it like that?
No, 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 no.
No.
It's like lap one. Okay, let's assume a cycling
Okay.
competition is happening. Okay,
Okay.
the once they started from a checkpoint, right? Let's assume I reach
Okay.
first. Okay,
Okay.
now
Mm-hmm.
before going to the next, okay,
Okay, you have to
lap.
wait for the other two to reach.
So let's assume in first lap I win, right? In second lap, the
Okay.
same process will repeat for multiple time for multiple checkpoints, right?
Okay. Okay, I
So
understand now. Yeah.
each checkpoint is a barrier, right? And all cyclists, wherever cyclists are there, 4, 5, must wait for each other before proceeding. Okay.
Okay. Okay. It's like one thread is completing its task, but it has to wait for the thread 2 and thread 3 to complete it to start the second process.
Yeah, I will just explain in simple word. Okay. The
Okay.
you just understand. Let assume uh if you use countdown latch. Okay. So countdown latch once become 0, you cannot reset it, right? For one lap
Okay.
you can use
Okay.
countdown latch. Okay. But for
Okay.
next lap
Okay.
you cannot reset it, right? But in
It
cyclic
is
barrier,
zero. It is
in
zero.
cyclic barrier, if all the thread reach a point, I can reset, I can reuse that one.
Okay.
You
Okay.
understand?
Yeah, I understand now.
Yeah. So you will understand like so this is also like pretty straightforward. It's not much difficult. Okay. So it's like
Yeah.
see there is let assume there is a checkpoint. Okay. So
Okay.
first cyclist reach the last checkpoint, then third reach, then second reach. Once all reach to the checkpoint, then race continues. Okay. Then again, cyclist 1
Okay.
start for the next lap. Cyclist 2 start for the next lap. Cyclist 3 start for the next lap. Right. And again, I can reset and
Okay.
again I can continue. So it's totally depend upon me how many laps I am going to
How
have.
many
Right.
laps here? Yeah, okay.
Yes.
So it is like two thing. You should know the number of count of the thread and I mean and also the number of count of the barrier.
Barrier, you reset, you can use
Or
multiple time. Right. So if,
okay.
yeah, it's kind of, so
Yeah,
it's kind
it's a
of,
kind of like that.
uh,
How
so
many times you are going to reset it and how many thread is involved, something like that.
correct. So here also the
Okay.
barrier await, right? How in
Okay. Yeah.
countdown latch it's await, right?
Yeah.
So here also it will await. Okay.
Okay.
Here
Okay.
it will also await. Here also it will wait for all these three. Once three reach to the certain. So you just how I can say that. Uh, basically forget about cyclic. Okay. What is
Mm-hmm.
barrier? So barrier, if you see in maybe in India you will see that in railway crossings, right?
Mm-hmm.
So
Yeah,
what happened?
it's there. You have to wait for the train. It's across,
Train to cross and then
and then you
train
have to
cross
proceed.
basically then they remove the barrier. Okay.
Yes,
Here it's
yes.
like a barrier, like everyone reach their
You
starting
should.
point. So they are having a barrier.
Yeah,
So no one should start first, right?
yeah,
Like
yeah,
once they up the barrier, then one lap, then once second lap done, then third lap. So like that. Okay.
yeah,
We'll see. Will think through, you can easily get it. Okay. It's not like much difficult.
yeah.
See,
No,
coding
no.
is
It's
straightforward.
actually the concept is this two concept is yeah. It's okay.
Yeah.
I
So
can
let assume
understand it.
first I will take a class. Okay.
Okay.
Cyclist or motorcyclist, whatever it is. Okay.
Okay.
I will take cyclist. Okay. Similarly, how friends are doing, right? Extends thread,
Mm.
right?
Right.
In that
Okay.
example, I was creating a reference of countdown latch. Here I will create
Barrier.
barrier.
Cyclic
Cyclic
barrier.
barrier is a class. Okay.
Okay.
So I just BRR. Okay.
Okay.
Cyclic barrier. Now I have a constructor, cyclist. Okay. And then we
Okay.
need a
String, yeah.
thread
Pass the
name.
name,
So
thread
name I'm
name, and
passing cyclic
the
barrier BR,
barrier.
and then here it's pretty straightforward.
Super.
Okay.
Yeah, super.
Name, and then here
And
I have this dot
this dot
BR
BRR
equal to
BR.
clear.
Yeah.
So
Yeah,
till
yeah.
here it's clear. It's pretty straightforward.
It's
And then
yeah.
even in run also it's kind of same. The
Okay.
only thing is that
Same.
in that one we are awaiting. In that one we are awaiting in main, right? And in
Okay, yeah.
inside a run
But
we are doing countdown latch down. But in this one inside run only we'll
we are
await.
going to await. Oh, okay.
Yes. So here
Oh, you're
I
going
would like
to put the await statement in run, override it. Oh, okay.
yes void run. Okay. And then
Okay.
so if you use await, right, it's may
Mhm.
thread it may throw a checked exception. That is the reason we have to handle it as well. Okay.
Okay.
So this is try, and then I will write system.out.println. Okay. And then I will print
Yeah.
current thread dot get name.
Get name.
So and I will also print reached checkpoint. Checkpoint. Okay. And once it's reached the checkpoint, okay, the barrier dot await. So here each barrier is waiting for other, and then system.out.println. I'm printing thread dot current thread dot get name. I just once all reach here, right? Once all reach, what we are
Okay.
doing? We are starting for the next lab.
Okay.
Next lab. And then this is done. Catch exception E. Right? And then everything close. 1, 2, 3. Okay, only 3. So this method close, run method close, main method close, class close, right? Okay.
Yeah.
So now we have created. So now what we have to do? We have to create a cyclic barrier first, right?
Yeah. In public
So what I will
main
do
method.
in main, let's assume I'm in main method. Okay.
Okay.
I'm just writing the code
Yeah, sure.
because we have only 5 minutes or 10 minutes left. So,
Okay.
so here is cyclic
Barrier.
and then BR equal to new cyclic barrier.
Okay.
Barrier. Okay. So this cyclic barrier, we can pass 4 or 5 or 3. I'm passing 3. You can also pass here runnable. Okay, runnable you can pass like that.
Runnable.
Runnable in the sense a run method like what we call public void run. Understand? So it's kind of thread reference. You can pass it here directly. Okay. So what when you reach this point, right? Barrier await. So when you reach this point, see this BR await, right? So it will print all reach to checkpoint. So how it will print? To print that, you need to pass like this. Okay. So you will learn this also. I'm directly using this. This is called a lambda. Okay. Java 8 way to write a code. I will just write here. All reached checkpoint or barrier point, whatever it is. So once all the thread reach to awaits, it will print this and then it will start for the next lab. Okay. So you declare in the main class like this. Tomorrow anyhow I will type this one in console. So today just for understanding. So I'm creating 4 or 3, whatever, how much thread you want to create, you create. So new cyclist. So first cyclist name is Avinav. I given name Avinav, and then what is the barrier? BR, and then start. Why you are using start? I created thread here. I'm starting that thread, right?
Okay.
New cyclist Rohan. Start. New cyclist Karthik. Dot start. Clear?
Yeah.
Okay. This piece of code, right? I can pass your object as well, means a runnable type object. Reference here. Okay. But this is the pretty straightforward way to do that. Okay.
Okay.
So whatever message you write here, once all the thread reach to checkpoints, this specific block will get executed. Okay.
Okay.
So clear?
Yeah.
So how will you get the output? You will get output when you start Avinav reached, Rohan reached, Karthik reached, and then here all whatever message I pass here, right? All reached the checkpoint.
All checkpoint.
All reached the checkpoint. Okay. And then Avinav starts next lap. Then Rohan start next lap. Understand? Okay. So how much time remaining? 6 minutes remaining. Okay. So major question they will ask, what is countdown latch? You can explain, right?
Yes.
What is cyclic barrier? You can explain, and you can explain this too. And even you can write a certain till, like if you practice this code 2 to 3 times, you can write code as well, right?
Yeah.
So it's not difficult. It's pretty straightforward. Like people keep this thing in advance, but what I figure it out, like this is the easiest than synchronized keyword. Okay. Okay. So they will ask you, there are 2 questions. What is countdown latch? What is cyclic barrier? The major question, what is the difference between countdown latch and cyclic barrier? So what I will say? So we'll say the countdown latch we can use for one-time event, right?
Yeah.
Cyclic barrier
You can use for
we can
n number
reset,
of.
we can reuse
Yeah.
it.
Reuse.
In countdown latch, we are waiting for multiple thread to finish before we proceed, right?
Proceed. Yeah.
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 In cyclic barrier, we are synchronizing thread at a checkpoint. So all the thread must reach to a certain checkpoint and then we will start.
Start the
Right.
process.
So here in countdown latch, it's like waiting for multiple thread to finish before we proceeding. But in cyclic barrier, it's like all reach to a certain checkpoint, means we are synchronizing the thread in certain way, right? It's not
Yeah.
like one is in 5th lap, one lap is not completed. We don't know the first lap result. Understand? And one person is completed of a 5th lap. So it's not like that. Okay. They will ask you real-time example. You just give an example of cake cutting and motorcycling race or car race or cyclist race. Okay. Cycling
Okay.
race. So this is all about countdown latch and cyclic barrier. Okay. And these
Yeah.
are the part of thread communication. Or you can say that this also you can use for thread synchronization. Basically, we are synchronizing the thread, right? But there are piece
Okay.
of communication also happening. How communication is happening, the people, like we come to know that, okay, X thread is reached, then Y, someone is keeping a record, right? Someone is taking care of communication. Then only like we come to know that, okay, 3 threads reached a certain point, right? So
Yes.
we can say that it's help us to synchronization as well as in communication. So anything, any doubt here?
No, actually these 2 concepts is as you said, it's pretty straightforward.
Yeah, fine. So tomorrow, what we'll do, the logs also, we have been through type of logs and what and all type of logs we have. So only pending is with this latch, cyclic barrier, countdown latch, and logs example, that in one class we'll finish it off, and then we'll see. There are in multi-threading, there are many concepts. Okay.
Okay.
So we'll cover one. There are many things like we'll read joins, and then we are having executors framework also. Okay.
Okay.
So that we'll
Okay.
leave right now. Once the Spring Boot is done, we'll see that.
Okay.
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 Fine. Thank
Yeah.
you.
Yeah. Thank you, Evan.
Yeah.
Thank you.